Hi, everyone. Let's talk about wormholes. Now, I'm sure you've heard of wormholes through science fiction movies and things like that. Now, wormholes are not just the invention of science fiction writers. Actually, the whole concept was originally described by the equations of general relativity created by Einstein way back in the over 100 years ago. And the idea was discussed by Einstein and one of his collaborators named Rosen in the mid 1900s. The official name for one of these things is called an Einstein Rosen bridge. So if you want to show off your science knowledge, you may use the official name, the Einstein Rosen bridge. As we talk through these, please keep in mind these are in theory, they exist. The mathematics exists for them, but as of this moment in time, they have not been observed. And will they ever be observed? I don't know. That's the fun of science. We can say the math says they could happen, but that doesn't mean they necessarily will happen. So, what exactly is a wormhole? Well, black holes are extreme types of gravity. So, if you have the fabric of space time, and you take something like a black hole and it causes a curvature of that space-time to such an extreme amount, it's theorized that it might puncture or rip a hole in space-time. In the same way that if you have a bed sheet and you put something very, very sharp and pointy on it, it might rip a hole in that bed sheet. Well, it's possible that a black hole might actually rip a hole in space-time. And if it does, it will have an way in and possibly a way out. And something that can flow like water flowing in and out of it would be a wormhole. But instead of having water flowing in and out of a pipe, you could be energy or matter that could flow through a hole in space time. Now, the term wormhole was originally coined in the 1960s by a gentleman named John Wheeler. He's also the gentleman who coined the phrase black hole. He's very good at naming things, and it's a very catchy name. And the idea is from the idea that if you had an apple and you had a worm that was going to eat its way through that apple, perhaps a black hole could eat its way through the fabric of space and time. Why are these so much fun to talk about in science fiction movies? Well, there's nobody says that space-time has to be flat. You and I imagine that the Earth is flat, and we know it's not. You know, you and I get in our car and we're driving from one point to another, and we imagine as we go down the highway, we're driving down a straight highway, but we know we're not. If you drive from New York to Los Angeles or the West Coast to the East Coast, you are actually going on a curved Earth. And your car, if you travel a long enough distance, is actually following the curvature of the Earth. So you are traveling on a curved path whenever you travel. I think it's more than 9 miles or something like that. You actually experience the curvature of the Earth. Well, this curvature of space and time is all the way or all around us, and we don't know exactly how it curves, but nobody says it has to be flat. So here's how wormholes could help us and help us in traveling. Let's say that I wanted to travel from this point, and let's call this point A, to another point some distance away, point B. And maybe if I had to stay in normal space-time, I had to follow the normal curvature of space and time. I'd have to go keep in space and in time, and I'd have to go all the way from A to B, and maybe that is 40,000 light years. Now that means that light would take 40,000 years to go from A to B. No human lifespan is going to survive 40,000 years going from A to B. But if there was a wormhole from A to B, maybe there would be a shortcut. I could go in A and out B and not have to go around on space-time. I could cut through space-time. It would be a fabulous shortcut through the middle if it would work. Now, some of the challenges with this wormhole travel. What is making these wormholes? Well, they're black holes as far as we understand them. And what do black holes have? They have extreme large quantities of gravity. So that if we actually could go in and out of one of these, we would be squished down to nothing. Our protons and electrons would be collapsed into neutrons or something even tighter and smaller. We're not too sure what. This would be an extremely not pleasant ride. We would not come out looking anything like what went in, as far as we understand right now. Wormholes, as I mentioned, is theoretical at the moment. One of the things that astronomers are looking for is a white hole. If lots of stuff is falling in one end, then it should be popping out the other end. And they have coined the phrase white hole, and that would be a spot where lots of energy and light is just spewing out the other end. So far, these have not been seen, but that is hypothetically, possibly the other end of a wormhole. Will we discover these in my lifetime? Maybe, maybe not. Don't know. That's half the fun of astronomy. But they are certainly a lot of fun to think about and wonder. And will there be itty bitty ones that we can maybe just send data and information through? Who knows? All right. Next time, we're going to talk about different kinds of black holes. We'll see you then. Bye bye.